Hey guys, welcome back to MathsCube. I'm really sorry for not being active over the past 3 to 4 months just because I was busy doing my major. So I hope I'll be consistent this time posting the videos. So without further ado, let's get started doing this paper which is of Pearson at Excel International Advanced Level. That's a new module, Mathematics, Pure Mathematics P1 of June 2021. So let's get right into it. So the first question is a very basic differentiation question where you can see the curve C has equation y equal to x square upon 3 plus 4 upon root of x plus 8 upon 3x minus 5, and where they have this with x greater than 0 as the domain. Now most of the people don't know how to handle this stuff, but whatever this is, what you have to do is just put the x value as equal to 0 and then substitute it back into y, and you'll get a math error. So this tells us that our x value has to be greater than 0, and the next step is to find the dy by dx, giving your answer in simplest form. Next, what I want you guys to do is just write the y value as the simplest form, which is x square upon 3 plus 4 upon a root of x, which will become, okay, so this stuff will become 4 into x to the power minus half plus 8 upon 3 x to the power minus 1 minus 5. Now I'll tell you guys how this root of x has become x to the power minus half. If you guys know the basic script that root of x has a value of x to the power half, so that's the same. So what happens is when you change something from the denominator, I hope this spelling is correct, to the numerator, so what happens is the value of the power changes. So something, if something is a positive value, it changes to negative. If it's negative, it changes to positive. So our next step will be to differentiate this y is equal to x square upon 3, which will become, if you guys know the basic differentiation, which is multiplying first, so that's going to be 2x, and then subtract the value of the power is subtracted by 1, so that will become 1. So we don't need to write that. That will become 2x upon 3 plus okay, so minus half is being multiplied by 4, and that will become a negative 2. So remember, you have to write your signs correctly. So that's 2x minus 1 upon 2 minus 1 becomes minus 3 upon 2, and then minus 1 into 8 upon 3 has minus 8 upon 3x minus 2 minus 1 minus 1 is minus 2 and minus 5. So constant, if you guys know, the differentiation of a constant is 0, so we don't need to write that. The last and the final step will be to clean this up. Actually, this is the final answer itself, but what I'll do is I'll write this in a very neat way, which will become 2 upon x to the power 3 upon half. That will become the half, oops, will become half plus minus 8 upon 3 x square, and this is the dy by dx, the very first part, and that's 4 marks granted very easily. Now moving on to the second part. Next part is the b part, which is the point p 4 upon 3 lies on c, and find the equation with number to c at point p. Write your answer in the form ax plus by plus c equal to 0, where a and b, c are integers to be found. So if you guys remember that the point p can be seen that is lying on c, this means is that if you put 4 here into the x problem, you get 3. So what they say is they have given the points as p 4 3, and they're asking us to find the equation and write it in this form. So what we're going to do is we're going to plug this x value into the dy by dx form. So if most of the guys don't know that dy by dx is also the gradient, it can act as a gradient of the original problem, which means that I'll be writing m as a gradient and then plugging in 4 to the gradient, which is the differential of the original problem. This is going to be 4 to the power 8 square, and if you put that into the calculator, you'll be getting 9 upon 4. Now they said that find the equation of the normal. So this equation is at the tangent. At default, any equation is at tangent. So we have to change it to the normal. And to change to the normal, we know that the gradient is the reciprocal, the negative reciprocal of it. So it will become, this will become negative 4 upon 9. So this will be our new gradient. So we have got our gradient as minus 4 upon 9. We have got our points, that's 4 and 3, x and y values. And now we have to find the equation of the normal. So guys, if you don't remember the formula of the equation, to find the equation of the normal, that's given in the back of the paper, and you don't have to worry, but it's good to remember that's y minus y naught equal to the gradient into x minus x naught. Now what we have to do is plug in the values. Y naught is the 3, which is y minus 3, equal to the gradient 4 upon 9 x minus 4. Now just simplifying that, y minus 3 is equal to minus 4 into, that become minus 4 into 9x. Minus 4 upon 9 into minus 4 will become positive 16 over 9. Now guys, we can see that there is integer and a fraction here. So to remove the fraction, what we'll do is multiply both sides by 9. So we'll multiply both sides by 9, and that will become 9y minus 27 equal to minus 4x plus 16. And now to remove the this value minus 27 to the other side and bring 4x to the other side, which what we do is we just substitute this back here. So that'll become 9y plus 4x equal to 42. But see that you have to write your answer in the form of ax plus by plus c equal to 0. So we have our ax, which is this one, we have our by, and we need to find c. Oh, we have c, but we have to put it right here. So that will become 9y plus 4x minus 43 equal to 0. And now that equation has become completed, and that's our 4 mark. And that's how you solve the differential question with the gradient in it. So thanks for watching guys, stay tuned for more videos.